morning, guys. Now we are going for one more problem of composite slab, a composite wall. Now the problem is like this: a composite slab consisting of three materials with thermal conductivity of 20 watt per meter degree Celsius, 30 watt per meter degree Celsius, 50 watt per meter degree Celsius, and a thickness of 0.3 meter, 0.15 meter, and 0.15 meter respectively. Okay, the outer surface is at 20 degrees Celsius and the inner surface is exposed to a convective heat transfer coefficient of 25 watt per meter square degree Celsius and a medium at 800 degrees Celsius. Determine the temperature distribution within the wall. Now observe, he has not given any figure. You should write a figure. Now what he has given? He has given three conductivities means there is a three different materials are there. Now I will take K1, K2, K3. Now what is the dimension here? Thickness is given. That means 0.3 meter, 0.15 meter, 0.15 meter. This will be act as our length. Okay, 0.3 meter, 0.15 meter, 0.15 meter. That is what given. Then here two surfaces are required. One is inner surface and is our outer surface. Now I am considering this as the inner surface and I am considering this as the outer surface. Now here outer surface is at 20 degrees Celsius. That means temperature is given here 20 degrees Celsius. At the inner surface is exposed. See, now this is exposed to your convective heat transfer coefficient, that is 25 watt per meter square degree Celsius, with the temperature of that will be 800 degrees Celsius. That means T infinity is 800, H is 25. Okay, this is what the given problem. First you should write the figure. Now after this, what do you want to record? How many number of elements are there? 1, 2 and 3. That means 3 elements are there. Now you have to model first, you have to model your FEM. See one thing, if area is not given, always assume area will be equal to 1 meter square. It is constant. See everything you want to calculate for meter square. Okay, per unit area means you can take it as a 1 meter square. Now see what is FE model? That means how many number of nodes are required? 1, 2, 3, 4. That means 4 nodes are required. Now locate 1, 2, 3 and 4. Now join this, join this, join this. Now you know this is L1, this is L2, this is L3. L1 is 0.3, 0.15, 0.15. Okay, this is given. Okay, in between this, okay, that you can write it. Then you can write on here. Okay. Now this is T1 is the temperature here, T2 is the temperature here, T3 is the temperature here, T4 is the temperature here. We know temperature T4 is 20 degrees Celsius. That will be equal to your T0. Now here this is convection is acting at this particular point. That is H value is given. That is 25 watt per meter square per degree Celsius, and T infinity will be equal to 800 degrees Celsius. Now how many number of film? 1, 2, 3 elements. Now what do you want to make it? First thing, if you want to solve the problem, first you should calculate your conductivity matrix. What is your conductivity matrix? Elemental conductivity matrix. Now we know that how to calculate your elemental conductivity matrix. That is your step 2. Now come to your elemental conductivity matrix. Elemental thermal conductivity matrix. Elemental thermal conductivity matrix. What is your general matrix? K equals to A into K divided by LE 1 minus 1 minus 1 1. A is the area, K is your thermal conductivity of the material, length of the element 1 minus 1 1. Now K1 equals to A1, K1, L1, 1 minus 1 minus 1 1. Now we know that what is the area? 1. What is K of first material? K of first material is given as, what is K value for first material? Now just here K is, you can write on here, what is K given? K is 20, here 50, not 50, 30 and 50. That means 20, 30, 50, 20, 30, 50. First one, 20 divided by, what is L? L is 0.3, 1 minus 1 minus 1 1. 1 minus 1 minus 1 1. If you calculate this, you are going to get 66.67 minus 66.67 minus 66.67 66.67. This is what you are going to get it. Now so repeat same thing. Next K2, because second element is K2. 1. K2 is, what is value? 30 divided by 0.15 into 1 minus 1 minus 1 1. Now if you calculate this, 200 minus 200 minus 200 minus 200. Now first element, if you take, what is the nodes for first element? 1 2 1 2. What is the nodes for second element? 2 3 2 3. What is the meaning of it? See, this values are belongs to element number 1. Then nodes 1 and 2, nodes 1 and 2. This belongs to element number 2. That is nodes 2 3 2 3. Now similarly calculate third one. What is that? 1 into 50 is the your given value 0.15. 1 minus 1 minus 1 1. What is this? This is K given. K1 20, K2 30, K3 50. Calculate it. Then after this, what do you want to make it? You want to calculate your global matrix. How to calculate your global matrix? See how many number of nodes are there? See this, you can take it 3 4, second third element 3 4. Total number of nodes 1 2 3 2 3 3 4. That means in row wise 4 values are there, column wise also 4 values are there. Then my matrix should be 4 cross 4. First row, you know how to do it this, like you are simple, you have done it in your stiffness matrix. minus 66.67, this is 0, 0. Now come to second row. Second row is first row should be equals to first column, 66.67. Then this is 0, this is 0. A22, 22 is there. Just check it. 22 here it is 66.67. This is here 200 is there. That is 266.67. Okay, 266.67. Then similarly, next one, 32. Is it 32 is that? 32, I think there is no 32. There is no 32. 32 here it is there, minus 200. Okay, then 42, 42 is not there, 0. Okay, come to next one. This should be equals to your, this is okay. Now come to next 33. Check it, 33. 33, 200. Here 33, 533. That is 33. That is 533.33 minus 333.33. Okay, then minus 333.33. And this will become 333.33. This is what you have to calculate your global matrix. 4 cross 4. Okay, this it is a repetition of your previous derivation what you did it. That means previously you have done your stiffness matrix for elements. Okay, same concept. Now, what is the next thing you want to calculate it? So you want to calculate your next thing you want to calculate is convective matrix. How to calculate your convective matrix? How to calculate your convective matrix? So to calculate your convective matrix, we know that at node 1, see where is the convection is acting. See, convection is there at node 1. See, convection is present at node 1. There is a convection, correct? What is convection is about? Say heat loss to the surroundings, because some fluid or anything is kept, that heat is transferring to that fluid, okay, or surrounding. Now what is that for your this one basic your equation HEAH 1000. See, this one always vary depending upon node. See, first node means, because what is this 1 2 1 2, you will write like this. If you take any element, first node is this, second node is this. First node value is this. Say this belongs to completely A11 belongs to node 1. This belongs to A22. But now where is your convection is acting? 1 1, because of this 1 0 0 0. Now based on this, first at node 1 what is the convection is present? See, convection present, area is 1, H is 25. Now node 1 1 0 0 0. Now if you solve this, you are going to get like this. This is 25 0 0 0 1 2. This belongs to element number 1. Now apart from this, see no other way. See, second material is in a conduction, third material is in a conduction. If you want, you can write this. Otherwise, sometimes you can directly neglect it. Directly you can write a global matrix. But here to understand you, what I done, I written H2, because there is no any convection in second element. Try directly written, all the values will be equal to 0. That is 2 3 2 3. Similarly, third element, there is no convection, 3 0 0. Sometimes maybe if you are given there is a convection at node 3, then it will be changed. Okay, it will be changed. But here there is no presence, only node 1 it is there. Like this. Now you got same thing, 4 row values, 4 column values. Now write your global matrix. How to write it? 25 0 0. See, if you write it, this is your global matrix. Now after this convection, there is one more thing, is force vector due to free end convection. See, where is once again it is acting at node 1. The formula is AH into T infinity 10. Now what is A? A is 1. What is H? 25. What is T infinity? 800 10. Now if you solve this, you are going to get 20,000 0. That is for 1 2. Similarly, you should write for no element number 2. Element number 2, there is no convection, 2 3 0 0. Similarly, 3 4 0 0. Now after this, now write what is your next thing is what is your global F. See, global F is convection. That is convection. Global F is 20,000 0 0 0 0. That means 20,000 0 0 0. What are the next steps? See, now you got K matrix, now you got H matrix, now you got F matrix. Next thing is use your equilibrium equation for thermal. What is equilibrium? K into T plus H into T is equals to F. What is K into T? Already K we have calculated. Just substitute K value. Temperature. How many temperatures are there? How many temperatures you want to there in the problem? 4 temperatures are there. T1, T2, T3, T4. 4 nodes. Okay. Similarly, now what is H value? H is this 2500. This is that. Then T1, T2, T3, T4. 20,000. Now what is common? T1, T2, T3, T4 common. Now add these two matrices. Now it will become a global matrix. This is called global matrix, which is consisting of both conduction and convection. If convection is not there, directly I can write here 0 and directly I can solve the problem. But in this problem it is present. Because of this we have both convection and this is called global matrix of that is conduction and convection. This is your F matrix. Now what is the next thing? See, you want to apply your boundary condition. What is your apply your boundary condition? See, you should eliminate, we know the temperature T4. T4 is how much? 20 degrees Celsius is given. T4 20 degrees Celsius is given. See, if you apply boundary condition, you should eliminate 4th row and 4th column. If you eliminate 4th row and 4th column. If you eliminate 4th row and 4th column. See, if you eliminate it, you should write your matrix. What is your matrix? Write your eliminated matrix. What is your eliminated matrix? Just write here eliminated matrix. So just observe here. What is your eliminated matrix? So your eliminated matrix is 91.667. Okay, 91.667 minus 66.667 0 minus 66.667 0. Because if you observe this, If you observe this, this is 0, this is 0, this is 0. 0 into T4 is 0, 0 into T4 is 0. But when you come to third row, when you see your third row, see third row, if you observe here, 0 minus 200, 533. But there is this, if you multiply this with respect to T4, you can get a value. Because on value, you should shift it to equals. After the equals, then what happened? This value will be not 0, this value will change, because I want to consider this effect. Because only fourth on fourth column, but if you take this value, there is some value. If you multiply these two, there is a value. You have to shift it this. See, this concept will not come in your stiffness matrix. Why? Because Q1, Q2, Q3, their fixed nodes will make it as a 0, correct? 0 into anything is 0, but here it is not there. Temperature is given. Because of this node you should shift it here. This value you should shift it here if you want to reduce the matrix. See, that is what I done it here. Now just observe here. See, after reduction, see first row like this, second row like this, see third row 0 minus 200, 533, but there is one more value with respect to T3 will be there, T4 will be there. That is, see if you shift after equals, it will become minus is there, it will become plus 333.33 into 20 R. Generally, sometimes we will write like this, T4, 333.33 into T4. Why 333? Because the value is same. Now, right here, after this multiplication, right here, you are going to get this. You are going to get this. That means, what is the value? 66.6. Okay. 6666.6. Now solve this. How to solve it? See what is it? 99.67 minus 66.667. So this is T1. This is 67 into T2 is equals to plus T3 into 0. 0 is equals to 20,000 is one equation you are going to get. This is what one equation you are going to get. Then if you use second equation, minus 66.67 into T2. This may be 67. That's it. 67 into T2. Okay. So T1, not T2, T1 plus 266.667 into T2 minus 200 into T3 is equals to 0. This is one equation. Okay. Then if you solve it, 0 into T1 plus minus 200 into T2 plus 533.33 into T3 is equals to 0. So if you solve these three equations using your calculators, or you can use any other method, that means you can make this is one equation, this is one more equation, and this is one more equation. Solve these three equations, three simultaneous equations, you are going to get the answer. T1 equals to 305.25, 119.72, 58.075. Or if you want to write it in the form of a matrix, that is T equals to T1, T2, T3, T4 transpose. Now write it like this. That's it. 305. That is degree Celsius. Outside you can keep it degree Celsius. Like this you can write it. This is what, how to solve your problem when there is a three composites. That means three composite wall. The material, the composite is wall is made up of three materials. That is K1, K2 and K3. K1, K2 and K3. Thank you.